Welcome back, stats students. I hope you're having a successful time completing your distance learning assignments. Today and this week, we're going to be covering Chapter 11 using randomness. So before we get started, I just wanted to say a quick thank you to those of you who are watching these videos. I can't see the number of people watching the videos, so I know it's not all of you, but I do appreciate those of you who are taking the time to really learn the material instead of just doing the MyMathLab until you get it correct. So I appreciate those of you who are doing what is expected of you during this time. Our learning intentions for today, we are going to learn about the use of randomness and how simulations can help us determine the outcome of an event. Your success criteria is you understand the difference between random selection and random assignment, and you can confidently use a simulation to determine the likelihood of an event happening. So why do we want things to be random? Well, as statisticians, things need to be fair in order for any of our data and any of our experiments to for us to be able to use our results and generalize them to a population. So if we make our outcomes random, then nobody can guess the outcomes before they happen. And we want to be fair. We want to make sure we are taking into consideration all of the possible outcomes when we are making things random. So an example of this is flipping a coin. I'm going to pick heads or tails. Let me grab a coin here from my coin drawer. Okay, so I have a quarter. I know you can't see me, so I apologize. But I have a quarter. I'm going to guess heads, and I'm going to flip the coin. Fell on the floor, but it was heads. So, could anyone have, does the outcome match my choice? Yes, it did. But what about if I flipped this a bunch more times? It's probably not going to be heads every time. I just flipped it a total of 3 times. I got heads twice and tails once. So there's no guarantee that when you're flipping a coin, you're going to get the outcome that you want. And you don't know before flipping the coin whether or not it would be a match. So maybe some of you are arguing with siblings as we are going through this new phase of stay at home. So maybe your parents are having you flip a coin to decide, who gets computer time or who gets to pick the movie you watch or whatever it may be. Because coin flipping is in itself random. You can't guess. It's either going to be a head or a tail, right? It's not going to end on the edge of the coin. That's incredibly unlikely. But nobody can guess with 100% certainty that it's going to be heads or tails on any set flip. So as statisticians, when they randomize things, they don't think of it being annoying. They actually use it as a tool, because if you make randomness a tool, then you can generalize your findings to the entire population because there was no sort of underlying bias happening in your experiment. Remember, in the last couple sections, we've been talking about bias and how you can't use biased experimental designs and generalize your findings to the entire population. But truly random values are hard to actually get. This is just a funny comic. We have an accountant and he's just saying 9 and 9 and 9. We're not really sure if that's random. So it's not easy being random. It's actually surprisingly difficult to generate random values. Computers generate them for this constantly. Actually, your calculator, if you go to math and then probability, you can generate a random integer. That's what this randint stands for. So your calculator can generate a random integer for you. But what's interesting about computers is computers follow programs. So none of those values that they're generating are like truly random. They're pseudo-random. That's what this word means. Don't be freaked out by the fact that there's a P there. It means pseudo, like fake random, right? We're trying to make it random, but pseudo-random is good enough for most purposes that we can use computer-generated values. But there are ways to generate random numbers so that they're both equally likely and truly random. The best way to do this, and that give a fair and accurate picture of the world, rely on randomness. And the ways in which we draw conclusions from those data depend on randomness too. So Like our learning intentions said, we're going to focus today on random selection and random assignment. So I'm going to pause here. That was our little general overview before we dive in. I'm going to try to make these videos shorter in hopes that maybe more of you will watch shorter videos than a bunch of long videos. So here's a shorter video. We'll pick up in the next one right where we paused.